Hi everyone. I'm Ghaya. I'm one of the programmers for Al Ghroob team.
Hi everyone, I'm Hamad Ghaya, and I'm the main programmer for the Ghroob game too.
Um, okay, so the main idea of our game is it's a horror game and it's 3D. So um, Hamad is gonna show you guys how to do basic things like create the player, create the enemy as 3D objects, their movements, and the enemy AI system.
Yes. All right. So you can go explain what the Unity engine is, and what we will use it for, and we can explain the hierarchy, the inspector windows, the asset project windows, and the scene all in general. All right. So here we go. So this is the Unity engine. We are using it to program the game, prototype the game level by level until we get to the final prototype, and we have the game ready to build it for the market, for Steam, for itch.io, and maybe maybe we could export for the Nintendo Switch. So without further ado, let's check on Unity. So as you can see over here, we have the hierarchy over here. That's the Unity project for the low for the live stream. So this is the hierarchy. We have the objects in our scene over here. For example, this is the ground. This is the ground. We have the ground over here. We we started the ground, so we have. Oh, all right, no problem. Sorry. Okay, so this is the ground. We need to expand it a bit more, so we can have like a free. We can make the player more free to roam around and touch the mechanics of jump, maybe like walking, jumping, sprinting. Uh, so like over here, that's the inspector for the ground. We have the transform. We have a mesh filter which renders the cube itself. The mesh filter and the mesh renderer, they both work together to show you the cube itself. And then we have the box collider. The box collider, it's more like physics this description for it. It's it detects if other objects collide with it. We can have an is trigger function for it. We can have a center. The good thing about it is we can have a center for the collision. If we move the center, like the x-axis, you can see the collision goes the collision goes out bounds of the cube itself. All right. So now to start off, we want to, for example, if we want to make the player have control of the game, we can make for the player for the gamer a player, so they can interact with our world over here. So now this is the player. We have we prepare the player. We have the software. We have the main camera. We have the body of the player. We replace it as a capsule, and this is the flashlight. Oh, okay. Okay, let's continue. Okay, the inspector for the player we have added a character controller. This defines the main, like, the core mechanics for our player in order to program it to have control over it. So for example, here is the slope limit. For now, we will just use a cube as the ground. But for example, if we will have a terrain for the game, and we don't want the player to just go up the mountains, we need to set up a slope limit for the player so that they won't just climb up. And step offset, for now, we can like go and check on the radius and the height of the character controller. So if you see over here, we have that's the body of the player, but the character controller has its own body too. So if we, for example, increase the height, you see the capsule, it just expands, the capsule of the character controller. That we can define, like, that defines as the collision for the player too. So let's return it to the normal. Now, we need to, for example, if we play the game, just like that, we have the character controller and nothing else. And now the scene starts. But we need to like move the character, because if we just press the arrow keys or the WASD keys, nothing happens. So we need to set that up right now. So we have a script ready over here. It's really simple. That's the player movement, and that's the mouse movement for the camera. All right. So let me explain. We define some. Okay, let's start from the top until the bottom of the code. So in Unity, it has its own libraries, which have codes that are prepared for you to use them, which makes it like programming the game easy, like in long term. So for example, if I want to switch scenes, I could just go to Unity Engine.scene management. In this library, we could, let's see, so scene. I want to show you an example of a code. For example, switch scene, but it doesn't show right now. But for now, let's focus on the player movement. That was in general of the libraries. Now this is just, there will be an update, every time you initiate a script, you create a script, there will be a start, void start, and void update. So void start, whenever you start the game, the code over here executes once. In update, it's called once per frame. So for example, if your game runs at 60 frames per second, update will get called 60 times per second. All right, here we set up two float variables for the X and Z directions, and we get their axes. It depends on your preferences on the controls. In Unity, let me go to project settings. It's over here. Let's in the input manager. We have the axes. We have all the buttons over here. We can use them directly into the code. But over here, we have the horizontal. It detects the movement of the player on A and D. That's left and right, as well as the vertical, which is S and W. All right, so once it has access to these controls, we are good to go to use these X and Z to like move the character by using a vector3 variable. We called it move, which transforms the object that the script is in. So over here, we attach the script already. So like it will transform the object that's in there using the right directions as X and forward as Z. And it uses the character controller to like move the player. And this one is important. Time.delta time is used to like sync the movement with the frames per second. So if you have two devices and you like move the character, they will move at the same speed. But without time.delta time, you may see a slight difference, because like each device is different. So this is to make like the gameplay equal on all devices, like at the same time, keeping it constant. All right, so over here we go to the mouse look. So it's important to have a sensitivity, so that player, like if their mouse is if it may have some problems, or maybe the surface isn't that sensitive, they can like change the variable in the script, or like I can show you over here. It will be in the main camera. Yes, see, I set mine to 207, so that like I can move the camera without having to bother a lot with picking up the mouse out of the table. And that's transform, which is the player body. It places the center of the camera into like the player body, so that like you can feel like you're inside the player. And that's the rotation. It just records like when you move your mouse on all axes. It records that, and it will move the camera too. And this is important. If you don't want to like in some games, the mouse that just disappears because it just locks this cursor in the middle of the game. Without this, the cursor will just fly around. Like I can show you like after when we play the game. And here we go to the update function. We have mouse X and mouse Y, both float variables, as in the player we have float variables. And here we have the axes, mouse X and mouse Y, which doesn't go to the keyboard, this goes to the mouse, as it was defined over here. Let's see. Mouse X and mouse Y, yes, they are over here. And with that, that's the X rotation, and it gets the mouse Y variable. It decrements it. And we don't want the player, like if you go like, for example, if you keep moving the mouse up without the clamp, without clamping it to a certain variable, the camera will just go like this. We don't want that. So we clamp it to 90 degrees maximum up and minimum 90 degrees negative down. And that's pretty much, that's the local rotation. It uses the X rotation, as we said. That's the player body. That's the player body, and it rotates the player body too. With the camera, it rotates the player body. So, okay, I was going to say about the mouse being everywhere without locking it. So when we play the game, now it's just reloading. So now over here, you see my mouse? It just it's just going out of bounds. Just going out of bounds of the game. If I press forward, I can move around. The enemy doesn't have an AI yet. I will program it right now after we're done with the player movement and the mouse. And if I press mouse button 1, which is right click, it turns on the flashlight. But the problem is this flashlight is a point light. We're going to change that by showing you like the inspector of the light, it's point light itself. So let's fix the problem of the mouse by just undoing this comment. So now it will be locked at the beginning. When we compile it, it will update the script in the camera, which is inside the player. Now let's go ahead. Yes, see? Now the mouse isn't going anywhere, it's locked inside here. So that's what we want. We don't want the mouse to go out of bounds of the game. And if we want the mouse to appear, we just press escape and the mouse is here. We want it to return, we click on the game. So onwards to the right. Since this is a flashlight, we want it to point forward somewhere, like somewhere where the player is watching, not like everywhere. So over here we see the light. We just click on point and see there's spot, directional, and area. Area is for terrain, like since it's baked. If we have like a terrain from the art house, like a terrain with nature and trees and mountains, and we want a certain amount of light, we can use this. But for now, let's go for spot. Spotlight. Let's see. We go not directional. Spot is what we need. So that's the spotlight for us. We can just move it into the player. See? There is a slight difference. If you see the ground, you can see some light. We can increase the intensity since this is not really intense. We can increase the range. And like besides editing from here, we can also just drag it, the inner angle and the outer angle. Now we can't drag the outer angle. And if we click play, you'll see a difference. Oh, by the way, Ghaya, if you can like go to YouTube and see like the live stream chat and answer the questions. Yes, yes, I didn't realize that. Maybe I need to see them, to answer them. Just give us a moment and we'll answer the questions. Problem is the light isn't rotating. Oh. Okay.
Yeah, I was muted and I couldn't talk for the past 20 minutes. There's a question about like how the AI would interact with the player. So the answer to that would be like we have two systems in mind for the different levels. So the first level would be like mostly based on like audio detection. So there is a scene with that system that we set up as a prototype, and another one that would be visual, which is going to be using Graycast to like detect the player without like seeing them through objects. So that's the two different ways the enemy will interact with the player. and like we'll do it hit based. So like the enemy can hit the player twice and then they die and revive in their previous checkpoint.
Okay, we're just having technical issues while we're streaming, so forgive us for that. Alright, so let's check on the enemy. Oh, alright, good. I wanted to go to GitHub, but since I cannot share, like, I guess we can skip that. But let's look on the how we will use the enemy to like chase the player or like have it roam around the map. So for now, we have this enemy, which is just a body and a cube, and this cube just defines where the enemy is watching, the face of the enemy. All right. So if we want to have a component for the enemy, let's start with, since we want the enemy to move around, we can have a nav mesh agent, which is, it's too long. We need to shorten it. Yes, over here, the height. Yes, now it's short. That's the radius. Like everything is defined here for the enemy, like the speed, the acceleration. If the acceleration is low, it will just slowly reach until 3.5, the angular speed, how it turns from left to right. I'm not sure if I'm lagging the camera.
Hamad, I don't want to disturb you. There's another question. They're asking if it's possible to attack the enemy in this game or is it solely stealth-based? So the answer to that is you can't attack the enemy. You're just supposed to hide and reach the different checkpoints, avoiding the enemy. You can't attack him in any way. Like there will be like some small puzzles, like getting a key, and there will be like papers you can pick up to like know information about the different enemies. Because all the enemies that we're using are like based on Emirati folklore, and like they're things we've been raised knowing, like Duwais. If you're local or if you're Emirati, you would know Duwais. It's like a big deal here. So yeah, but you can't attack the enemy at all. Just run and hide.
All right, so we have the enemy over here. We can either add component and just write script. We have just click on new script, or we could just go over here, create. This is the way I prefer it. Just there are many things over here: material, lens flare, timeline, scene, like shaders. But over here, that's the C sharp. That's the C sharp script. That's what we want. We just click on it, and let's give it enemy live stream. So we're programming it from scratch. And as I said before, this is how every script is instantiated in Unity. You just have void start and update. They're empty, and these three libraries. So for the enemy, we want one library that we are going to use, which is the AI. So let's add it over here. That's the AI. Okay, let's make sure. Okay, yes, that's the I, capital I. All right. So for the enemy to detect the player, like let's define how the enemy thinks and how it stores, like what. Oh, okay. Pardon me. We need the enemy to know what the player is. So, for example, let's go public game object the player. This game object in the script will store the player, which when the enemy detects it, it will start chasing the player. but we don't want the enemy to start chasing the player like instantly, or just like know that the player is over there. So we need to have like a certain like variable that tells the enemy if like start chasing it or stop chasing it. So let's have a public bool chase. Let's set this to false. We can, instead of setting this variable to false, let's do it in the start. Chase is equal to false. Let's see. Now,
Hamad, there's another question. Someone's asking, do you have a different kind of detection depending on the enemy? So the answer to that would be, on the first level, the enemy is blind. So it will start easy and get hard. So the first level, the enemy is blind. All you have to worry about is like your footsteps, how fast you're walking, what the amount of noise you're making. And then we'll add to that in the level after that, and then they can see you. So you'd have to be careful not to be seen by the enemy. And then something else that we're also working on is the olfactory system, which is like based on your scent. So that enemy would be like blind and can't hear, but they can smell you. So like wherever you are, the enemy would release like particles that can be, the player would release particles that can be detected by the enemy. And that's it.
all right. So to explain what I wrote over here, I just realized that the script itself needs to know that there is a nav mesh agent inside the enemy, so it can access it. So we have the nav mesh agent for the enemy, and it gets that component. So it can have access to the speed, to the acceleration, to the angular speed too, and the radius and the height. All right. And we need to have like, okay. And I remembered one more thing. Since the enemy needs to have a path, let's call this the game object pathway. And let's set it enemy.set destination pathway.transform.position. So to explain what I wrote over here, as I said, the enemy chases the player. It has like the way we code it is that it's not like it's chasing, but it's following like what it's directed to do. So like the destination is set to be in the pathway, and the transform that position, like there is vector 3 and there is transform, but we're using the transform because if we go to the inspector over here, you see transform over here. So transform that position, so it gets the x, the y, and the z axis. So that makes it easy for the enemy to find the player or the pathway that we will set up. So now, since like there is no pathway yet, we need to create one. So let's do that right now. Let's create an empty. We call this a pathway. And now, like, this pathway is just empty. We need it to like be in certain locations so that the enemy like goes to these locations and returns. Like we'll program it to be in a circle. So let's have game object locations. As always, the position should be 0, 0, 0, so it won't interfere with the other transforms. Inside this, we have like we need to like organize the hierarchy so we know like what we're dealing with. So that's the pathway, which will have the pathway script, and the locations, which we will be dealing with as game objects. So we create an empty inside the locations. Let's say this is location 1. So if the enemy is over here, let's have the first location to be over here. Now let's not really complicate it, since we don't want a lot of locations, so we don't have to program them all. We'll just have the enemy walk back and forth, back and forth, back and forth. All right, we create another empty and we call this location 2. And location 2, let's see, that's location 1 and location 2. And location 2, let's leave it over here. So it's over here and over there. Let's see, there it is. They're not in the same level. Actually, let's make them up so that the enemy touches the locations. Alright, let's get concentrating over here. Because right now, we will introduce the box collider. The pathway, we want the pathway to detect if the enemy reached that destination. So let's have a box collider over here in the components. Box collider, yes. But we don't want the enemy just to click on the box like this. We want the enemy to pass through the box, like transparent. So we set this to as trigger. And with that, we have like the pathway is like ready, but we just need the pathway to be like in location 1 and location 2. So let's write down the script for the pathway. Pathway live stream. Alright, it's a bit lagging over here. Actually, let me make sure. Is the script out yet? Okay, yes, it's over here. So, since we programmed 2 locations, let's have public game object, location 1. Can I check? Are there any more questions? I'm a bit concerned. Public game. Location 2. We have these 2 locations. Now, you want to answer that? Oh, yeah? Your microphone. Oh, okay.
So it's based on the nav mesh. So you tell, like, if there's high terrain, the nav mesh like it decides where the enemy can walk or where he can't walk. So if you when you create the nav mesh, it like it allows you like certain slopiness that you can let the enemy climb. So you set that how much you want him to be able to go up. So that's based on the terrain.
Do you want to answer that, or I can answer?
You can answer.
Okay. So, like, there are many like ways you can like approach this, but Unity uses C#. If you don't want to like do a lot of programming, Unity has like a bot, which is a visual scripting language. You just use blueprints, or you can like use like prepared game engines that don't require coding at all. But what I'm using right now isn't Visual Studio. It's called Script Inspector 3. It's at the Unity Asset Store. You can buy it if you want in the summer sale, or maybe in the upcoming sales. And it's really like flexible. Like, you don't have to go to Visual Studio to edit the code. You just inside Unity. All right. So I just set up the increment to 0. I just want to make sure, since we have some scripts ready, let's make this easy and fast, which is the pathway over here. We just add we will look into that level in which we will use the raycast. Like there are many locations, yes, over here. So since we're using a trigger for the box collider, void on trigger enter collider other. So what's happening in void on trigger enter? If like there is okay, so there is on trigger enter, void on trigger stay, and void on trigger leave. Okay, void on trigger enter is when the enemy enters at the point like the code the on trigger and like the on trigger functions they execute like in the update. Void on trigger enter is when the enemy enters the collider at the same time. On trigger stay executes when the enemy is in the trigger place. On trigger leave is when the enemy leaves the trigger. But for now, we will just use one trigger enter because that's what we need. Let's have some code over here. Let's see. Let's close this. Let's paste this so we can, and we added this right here. All right. Right.
I'm not really a gamer because when I play like first-person games, I get this motion sickness feeling. So I'm not part of like the testing or like I don't come up with the ideas. Faris, our creative director, he's like the extreme gamer, and if like he was here, he'd tell you like a million games you should play, but I don't game at all.
As for me, one horror game, Slenderman. Just play Slenderman. It's just like the classic Unity game that you can find, the classic Slenderman. Other than that, that's what I recommend. So what I've done right now, here. Okay, this need to change, increment, and increment. All right, so we have for the pathway live stream. Okay, that will be inside the pathway object. Now we will have the two locations inside the locations hierarchy, which they will have their own triggers too. And now increment is 0. So let's fix something, or maybe I could make this an intentional bug. So we can have like some like response from the audience. So increment starts at 0, and then the enemy comes to the pathway, and if it detects, yes, I'm just remembering like using important things. There are important things I'm forgetting. Yes, this is one of them. This is just for the pathway. The pathway changes directions, but it needs to detect if what is touching the pathway is the enemy. Because if the player touches the pathway, then the pathway changes and the enemy is confused. Let's do that right now. Here in the enemy, I'm using the other.tag because there are layers and there are tags. Layers, you can use them for the water, UI, ground, and the tags, you can have lots of tags, as much as you want. So for now, let's have a tag. Let's add a tag. We call it.
Hamad, can you finish this off and then we can show them the GitHub thing, like how they can upload to GitHub for if they want to contribute to our game or create anything for us, like any of the systems that they have in mind for like enemy and player, since they're asking a lot of questions about that. Maybe they have ideas of like enemy detecting systems.
Oh, all right, 1 minute. Yes, I need to wrap this up like real fast. Not this one. This is enemy path, not pathway.
I think just show them the completed one in our level 1, or
Yes, that would be fun. That's oh, I see. So one problem I made, I need to make this double. Like in if statements, you don't because okay, if like there is equal and there is double equal. Equal sets up the variable. Double equal checks if it's the same and returns a boolean of 0 or 1. Okay, that's ready. Okay, that's ready. Then I need to switch screen to GitHub. All right. Okay, one problem is with the enemy. Like I saw like a bug right there. Yes, then. Yes, I need to instantiate the enemy to the pathway. I didn't do that yet. So it just the enemy is just the enemy is sinking. Why? I think I need to make the applications. Oh, is it? Oh, is it really the? Let me see. Because that's concerning. The enemy is sinking because of the nav mesh. Okay, let's see. Let's hear from the audience. Do you want to see the GitHub? All right. Let's see level 1 then. Because we were just looking like this is the process of like making a game. You just program, find bugs, try to see like the nav mesh agent. Why is the enemy sinking? Maybe like try to lift the enemy by changing the y variable of the locations, checking the pathway. Pathway needs like to have like to be a little bit up. All right. So far in our first level, let's see, will it load? Yes. Okay. To explain everything, that's the map that first drew on yesterday's live stream. Let's have an aerial look, view. I use the mouse to look. I'm pressing the right mouse button to look around, and WASD to move the camera. Okay, so this slice over here is where the raycast is working for the enemy. That's the enemy, but he just looks into that place only, and like it won't detect anything that's behind the rocks. We just set it up over here, blockades, which is the ground. The map over here, we set the layer to ground. Okay, so that's the player. We have the character contour, player movement. We have a collider too for that. The directional light, we can like control how bright the environment is, so we can have it real dark, or like let's have it light for now. So let's play that. Like keep an eye these up with all the mechanics, the player movement and the enemy pathway just roams around. I'll show you what happens when like I go in front of the enemy. So this is the flashlight. See, it's strong. The enemy is over there. For example, I'm sneaking, making sure the enemy won't see me. But if I click shift, I can sprint. I click C, I crouch. I cross the bridge. Bridge. Example, I see the enemy over there. Oh, the enemy sees me. He chases me, but for now there is no HP right now. since this is just a prototype to test it out. The enemy will just push me around, trying to kill me. Because the one problem is the raycast is too huge, so we can just manipulate that. For example, make the angle a little bit small, the distance a little bit small, so the enemy is over there, he won't see me yet. So that's one way to fix it. Alright, so let's see GitHub. Let's see if I can change the screen. GitHub. Let me see if I can. Alright, let me do this then. I'll share my entire screen. Okay, you guys. Oh, yes. Okay. So this is the GitHub Desktop. You can download it on Windows Store, or if you're on MacBook, you can just go directly to GitHub's website. If you have an account, you can download it from there. So over here, you can see that's the current repository. We have the Android Studios, since we are part of their account. We have we were testing it out, the integration of GitHub with Unity. Over here, these are the branches. The master branch is where the finished program is. So for us, that's how the most up-to-date prototype. And the recent branches and other branches, for example, this is my branch, this is Ghaya's branch, and this is the live stream branch, in which we are trying to set up for the live stream. And we are just working. And what's GitHub good for is that you don't have to use your device over here. You can go somewhere else using another device, and from that GitHub you download your branch. So that's one advantage. We just upload our simple changes to that branch. And for example, if we want to commit to master, now we're in the live stream branch. We just, for example, we push all of these changes onto the live stream. Now I don't want to change to master because it will bring all of these changes, which we don't want yet. But over here, let's see if we can find it. Yes, branch over here. We go merge into current branch. So for example, if this is master, and if we have changes in Hamad's branch or Ghaya's branch, we click on that when we create merge commit. And it merges, in other words, it takes the new files that we made and puts them inside the file. It doesn't erase other files unless we want it to. For example, maybe we deleted some files over here. We changed this file. We changed the nav mesh areas.asset, and the green ones, which is what we added to the project. All right, and fetching just refreshes our changes in the branch itself. So that's GitHub. Any other questions?
There's a question in the chat. They're saying that it might be too early in the process to ask this, but it's about the health system. In the event that the enemy hits you, is there a grace period given by the AI?
Grace period. Yes, that's a smart question.
What we were thinking is that after the first hit, the enemy will slow down for a period of time to give you a chance to run away, and you would be able to recover, but we don't want it to be so easy that you never die. So we have to find the value in between of how long the enemy has to wait between each hits, so that the player doesn't always get away, but sometimes they do get away. So we're still working on that.
All right. So for now, we are done with Unity and GitHub. Maybe next week, if Android Studios will give the programmers like a chance to look into our branches and maybe have their changes or add their Easter eggs. So it would be amazing to collaborate with us too. So let me see. I want to look into your questions as well. Okay, I stopped sharing. I just wanted to go to the YouTube video over here to see and answer your questions as well. All right, over here. Yes. Make it darker. Yes. Okay, are there any other questions before we close? Like, I'm sorry, I was just too committed to like programming, so I didn't see the chat at all. Like right now I can see like so many things. I messed up. Oh, why is Saqr over here? I don't realize that. What is going on? How is Saqr over here? I'm amazed. Whatever. Hopefully, when we get done with this game, you may see it in somewhere in conventions, maybe Uprising, maybe Aura Art, maybe Middle East Comic Con. So we can't wait for everyone to try it out. But thanks everyone. Thanks everyone for joining in. Let me see. Yes, and by the way, if you're in Discord, I'll be available right now after I'll close some windows, so I can like hop on into the voice room of Discord in the studios. Yes. So I'll be online in a moment in Discord. Like give. All right. So we're ending this. We're ending this in the most handsome way.
Thank you everyone for watching our stream, and stay tuned for the streams coming up. I don't think there are streams today, but tomorrow and the day after. Thank you.
All right. Goodbye, everyone.